Welcome, dear students. In this model, we will be discussing the construction, working principle, and applications of two-roll mill. In our previous model, we discussed various compounding equipments, the introduction to compounding equipments, compounding, types of compounding, etc., and also the types of mixing techniques, that is batch mixing and continuous mixing process. Now in batch mixing we are going to discuss two-roll mill, its construction, working principle, and its applications. First of all, what is two-roll mill? We will discuss elaborately about its construction. It is the simplest machine for intensive mixing. It consists of two horizontal parallel rows. These are the two rolls which are horizontal to each other, and these rolls are supported through these rolls. They are supported here and here. These are supported through strong bearings, that is frictional bearing in the mill frame. This is the frame, mill frame. So these are supported in the mill frame, and the rolls run at different surface speed. So these rolls run at different surface speeds. Normally the back roll is connected to the electric motors with reduction gearbox, so that it runs at a slightly higher speed than the front roll. And the gap between these two rolls is called as nip gap. So what is nip gap? The gap between the front roll and the back roll is known as nip gap. So the nip gap can be adjusted using this adjuster, so that the front roll can be moved forward or backward, so that the nip gap will be get modified. For heating and cooling purpose, these rolls, this is the heating or cooling purpose. These rolls are hollow in nature. Normally the back roll is rotated by electric motors with the reduction gearbox, and the gear attached to other end of the back roll, which mates with the gear on the front roll, the so-called coupling gears, and the ratio of teeth of these two gears determines the friction ratio. What is friction ratio? Friction ratio is defined as the difference between the surface speed of the two rolls. That is the difference between surface speed of the front roll and the back roll. Usually the back roll is running faster than the front roll. And the mill is equipped with the side guides, and these are the side guides. Here the side guides, which prevent the rubber or polymer material to flow from the nip to bearing. It prevents from the flow of polymer from the nip to the bearing. So this roll nip can be adjusted by moving the front roll. It can be operated either hand or by electrically operated or hydraulically operated. And the bottom pan, this is the bottom pan. It is available below the roll to collect the unwanted material or the fill material during mixing, and this material is placed again onto the roll by the operator, so that the polymer get mixed thoroughly. Then let us see the mixing operations. The material is placed onto the roll, and initially the material does not form a continuous band, and part of the material fell down into the bottom of the pan below the roll. This material is again placed on. This material is again placed on the roll by the operator with the shawl, with a knife. First, the compound is allowed to run on the front roll to form a band. First, if it is a front roll, say this is a front roll, then first it is allowed to form a band. The energy of melting and the softening of the polymer comes from two sources. One is thermal conduction from the hot rolls, and heat energy developed by sharing of the material in the roll neck. Once this band is formed, this is the band. Once this band is formed, then other ingredients of the mix is slowly added here. This is the ingredients which will be added here. These ingredients are immediately incorporated into the material on the mill. This mixing process is assisted manually by cutting the band. So the operator will cut this band with the knife from one edge to the other edge, so that a flap is formed which can be folded into the other side. This step allows the rapid exchange of bank. So this is called as bank. This is bank. And the band, this is band. So the thorough mixing is obtained by cutting and folding many times from both sides. Good distribution and dispersion is achieved finally. Once good distribution and dispersion is achieved, the entire batch can be removed. So the entire batch can be removed from the mill by cutting across the full width and pulling up the batch as a continuous sheet. So this is the operation by which the compound ingredients get mixed with the plastics, and finally we get the compounded plastics. So we have seen the various mixing operations, and we can get the good quality of mixing by controlling the surface speed of the roll and by controlling the nip cap. If the nip cap is small, then shear applied in the nip cap is high, so that the dispersive mixing can be obtained. And also controlling the size of the rolling bank. We can control the size of this is the bank, rolling bank. We can control this size so that good quality of mixing is obtained. And also controlling the temperature, roll temperature. Certain drawbacks also there. However, the two-roll mill mixing process . It is a relatively slow process. And this process is largely done manually only. So laborers are required, and it also creates health problems due to the dust formation. So these are the drawbacks. But finally we obtained a good batch of compounding mixed with using this Toural mill. Normally most of the industries have this Toural mill. It's a batch mixing process. So in this model we discussed elaborately about the construction, working principle, application, and certain limitations of this Toural mill. In our next model we will be discussing ribbon blender, its construction and its working. Thank you.